So column transforming, the goal is to start with panda data frames and come out with a well-formatted NumPy array that can easily be plugged in statistics such as scikit-learn. So it's a pre-processing problem. So often the way we get our data is we read it from a CSV file. So we could do this with pandas and we'll get a data frame that has different types and different columns. And our goal is going to be to convert all those values to numerical values. And let's look at gender. So gender, so it's a categorical column, and we're going to transform it to a numerical column. And the standard way to do this is to use one-hot encoding. So in scikit-learn, we'll use sklearn.preprocessing.oneHotEncoder, and then we'll call the fit transform method on the column gender, and it's going to output indicator columns with 0 and 1s that indicate the different genders. Okay. Now for dates, we could use the pandas datetime support. So pandas deals quite well natively with this kind of strings. It knows how to convert them to the datetime object. And once we have the datetime objects, we can take its value in float, and it's a value in, I believe, milliseconds to the epoch. And so it's a numerical value that is reasonably well ordered, and hopefully we can learn from it, hopefully. So something I'd like to stress is that in scikit-learn, we like to work with things that we call transformers. And if we look at the one-hot encoder, we can actually split the fitting of the one-hot encoder and the transforming. The idea is that during the fitting, we're storing which categories are present in the data, and during the transforming, we're encoding this data accordingly. So this separation between fit and transforming is quite important because it avoids data leakage between the train and the test set when we're evaluating the pipeline. And we can also store the fitted transformer and apply it to new data at predict time for production, for instance. And it can be used with a bunch of tools in scikit-learn, such as the pipeline or the cross-val score that is used to do a cross-validation. So for dates, it might be useful to shoehorn our panda code into such a process. And for this, we can use the function transformer. So we can define a small function that will take as input the pandas data frame, or the pandas column we're interested in, and then return as output a 2D array of numerical values. And for this, it's just taking the code that we were doing with pandas, putting it in the proper function, and making sure that we're returning a 2D output. And then once we have this, we can use a sklearn.preprocessing.function transformer, give it this function, and tell it that we don't want validation, because if we want validation, it's going to try to check that the data is well formatted at the input, and it's not, so it will complain. So function transformer can be a bit more clever. You can tell it how to inverse transform. It's a more sophisticated tool, and I won't go into details. What I just want to stress here is that it can be useful to look at the modern pre-processing documentation of scikit-learn, because it has many useful tools for this purpose. And once again, pipelines are good. Now, how do we put a pandas data frame in a pipeline and apply different transformers to the different columns? For this, we can use the column transformer object. The column transformer object will take a list of pairs of transformers and selectors of columns. And selectors of columns can be, for instance, column names. Okay? So here with this code, I'm telling that I want to apply a one-hot encoder to the gender and employee position title columns, and my date transformer to the date first hired. And now I can call the column transformer on a data frame. It will do all the magic and comes out an NumPy array. And so I can build complicated pipelines using this kind of patterns to get my raw data, at least my raw data frame, in, and then use scikit-learn on this. So this is useful for cross-validation, for instance. And the benefit really is that we can use all the tools in scikit-learn for model selection, such as, for instance, we could pipeline this column transformer with a fast gradient boosting classifier that's new in 021, and then just apply cross-validation on the raw data. Okay? So if you're not using it, you should probably be using it. If you think it can be improved, find an issue.